Hi, my name is Angela, and I wanted to go over updates to the Gulmer project. And I was going to make this more of an informational video just because, well, there's a lot that was changed, a lot that was added, a lot that I will change, so on and so forth. And I just thought, you change something so much, you should probably inform people a little bit about all the changes, even though, it's just one sliver of all the rest of the stuff that's going to change. So as much as it changed now, it'll change that much into the near future. So don't expect this video to be kind of concrete, but it will be an informational video of current changes. Anyways, I said to display the README at throughout this video in order to explain things and, help me, explain things a little bit more. I think there's some people who want to get into the neural network stuff with Go, but they don't quite know where to start or anything. I actually made a blog thing on my Medium. I'll link it in the video. That goes. I had more blog pages on it that explain things, but I just wanted something so that it was an initial thing. But the problem that kind of runs into, and I've covered this in other videos, is things get really complicated really quickly. Maybe the first step in neural networks is something you can put in your head, but then after that there becomes this issue of keeping it in your head. A lot of it has to do with math, and I'm also not that great at math, and that's also part of the reason why I did have some help with the vibe coding, because I don't have a background in it. I have a background in a lot of things that it does. So the reason why I bring that up is because you just kind of have to come to the understanding that you're not going to have a full mental model. It ain't going to be A plus B equals C. It's just not going to happen. And I understand for a lot of Go people that's a deal breaker or whatever. And I've got way too many videos explaining how important the mental model is, but you also have to understand that the complexity of the neural networks sort of, it kind of doesn't matter how simple the language is, and that's kind of the point. I know that doesn't make a whole lot of sense, but the magic of how it does the error calculating and the weights and bias fixing and so on and so forth, that's why the neural network is sort of misunderstood, is extremely useful, and can provide really interesting tools. If it was just 2 plus 2 equals 4, people wouldn't even be talking about it. But since it does this data manipulation, or if you think about like a business where CEO makes a guess, the managers get the memo, the workers then have to fix the weights and biases in order to do the correction based off of how misguided the CEO's guess was, and then the next epoch. But there's a lot of layers in between there and there's also a lot of multi-dimensional arrays that kind of get run through, and so your mental model of what's going on sort of dissipates really, really, really quickly. And so as I explain things, it's going to be at a high level, mainly because, A, I don't exactly have a big background in a lot of it, but B, you just have to learn to let go of your mental model of exactly what's occurring. You can deep dive into what you think ought to be happening, but at the baseline, it's just a bunch of numbers, some of them negative, that are many decimal places, and you're just not going to know to move something over in order to get this certain decimal number that you think will improve your program by a lot. There may be some data scientists that can do exactly that, but if you don't have that background, you got to do it with what you have. One of the biggest things I've introduced was it's not so much conversational AI as it is just right now it's kind of broken in a sense of its learning. I think prior I had a big idea of filling in data in order to control the conversation, but it really wasn't. It was more of a filler or structured conversation. So it was really a way to gatekeep questions and user input. Whereas this is more an attempt at trying to undo that structure or gatekeeping of the input. It's not a complete, but it's an attempt toward trying to do that. And why would you do that? You would do that because certain conversations you would have data structured a certain way because you need certain kind of replies. I think in the big general LLMs, they use that because of the sheer mass amount of languages and ideas and probably the different experts that it uses and so on and so forth, that it couldn't possibly calculate every single sentence and know exactly what to say with all context. Like, that kind of processing would be ridiculous. So I'm sure for them it's required because just sheer processing power. For mine, though, it's but merely trying to put a sentence together and respond in instances or many different kinds of training data, so that not geared toward any particular topic, but just a learning of how it would respond. And let me, I guess, give you I guess a dose of what that is. You just type in "how are you?" and the chat response is going through it, putting the sentence together, and it kind of gives you something, but it isn't quite exactly what you were looking for, obviously. But the point of that is, and this is only trained on a couple of epochs, it's not a full out trained thing. A full out trained thing would be a couple hundred epochs. I'm still trying to loosen the reins on the conversation so that I can use multiple experts, and then there's a whole deep dive into attempting to train the experts so that they're equally utilized, and so that's a whole ball game. That's why some of the output maybe prior was more correct, but now it's seems like it kind of became less correct. But that's because I added twice the amount of experts, and they're beginning to learn on their own how to put a sentence together, or how to respond or play their role. A big part of that, and hopefully it doesn't kill the video, is the training. And I'm just going to do this really quickly as just an understanding thing. I'm not going to actually go through it, just because I think it will end up screwing up the video, just because it has to utilize the CPUs a lot. And there's a lot that goes into this. I've been doing it pretty much daily, and just having this was, even with the vibe coding, took pretty much forever. But as you can see, it's trying to load the GOB files. There's certain capacities and weights and temperatures and dropouts. And dropout is basically, let's say you have a customer that doesn't react very well to things. They're just terrible customers. And you're trying to fix the weights and biases to incorporate a more correct answer based off the error value. Well, dropout is kind of like the RELU function, and that it just kind of filters out deviations of some that's a little too good, some that's a little too bad. It's the bad customers. They're not gonna, they fill out surveys swearing up a storm. It's just not useful to the company. It's not going to get you any closer to the actual guest that the CEO wants, right? And so there's certain functions that you need in order to do that. And I'm pulling from all different kinds of training sources. You can find these, I believe, under training data. And there's a whole bunch of different semantics and vocabulary and conversation and books and so on and so forth. And the point of doing a lot of this is you could just take a conversational training data and train it, and it may react very well to it, but you want it to be able to develop structured data in and of itself, not you programming it. And that's important because different people use it for all different reasons, and I don't want to have to program for each and every single reason. Not that it obviously does it all that well right now, but I'm attempting to get there. So yeah, it'll give a big giant readout to that. That I kind of gave you an idea of why you would want something like that. Here's kind of the breakdown. The initial reason was to understand developer commands, and I went over to some videos where I just didn't want to remember commands anymore. I also didn't want to pay for tokens in other LLMs, and so this would be a way to get around that. General conversation, I mean, I don't know what that really means, especially in the form of CLI and commands, but I'm attempting to do it so that it develops its own schema of conversation. Here's basically a general readout of what's actually going on. You type stuff, it then tokenizes it, and really what that is just giving words numbers based upon sentences that it's already trained on, so that it can weigh the balances between trying to get the next word, and then also what sentences as well. And I showed in other videos the tokenization, the layering of it. Tokenization is not the neural network. That part is just simply filtering and using rejects in order to add layers so that the tokenization isn't just per word, or it's just only looking at the next word. It also uses other means in order to guess how to make a sentence. So there's the backward functions and the forward functions. I don't know if I'm going to screw this up between the two. A lot of times I'll do that. And I wrote in the blog exactly what they mean. But basically, one is the guess. What happens when the CEO makes a guess and brings the memo down to the managers, and then what accumulates based on that. I put it all into the blog thing, and I explained it fully. Whereas I believe the backwards function is, the correction part. Did you guess it right? And what do you need to do next? This hybrid LLM GNN is just another name for another kind of model that, like the MoE model and everything, and it's just a really high level version of what I explained about the CEO and the manager and the workers, and what the neural network needs to do in order to make the correction. It's just a newer version of it. Yeah, I mean, if you want to look it up, it gets pretty complicated though, but that is somewhere I used some vibe coding in order to work out, I guess you could say, because I don't have a background in any of that. And there's a lot of them. And they have a big historical aspect to them. And being able to build it out from scratch while still having it in your head, I wouldn't even trust that, even if somebody did do it. Only because Depends what you're building it for, depends on what kind of data you're using, depends on the conversation you're having, depends on, what it is you're trying to do. And for someone to break it down simply and then keep it simple somehow, and its use case probably wouldn't be all that useful. It would just be a simple example that would have simple use cases, and yeah. So the intent classification, I made videos on it before. It's just that's where it was more strict conversation. It wasn't even conversation, it was more like it trying to guess what your words mean. And these are the different kind of intents. Yeah. And a lot of this comes down to word guessing, tag guessing, and and trying to make some logic so that it fills in the JSON so that it can guess what it is you're saying. It's not the most neural networky thing to do. It's just a thin layer above tagging, because it's just like utilizing that in order to guess the intent, which with tagging and filtering you can do pretty well and fake out neural network stuff. But the thing that makes a neural network is the guess. If there's no guess and it's just kind of filtering, I guess maybe you could, no, because you have to do some kind of fixing, and the filtering isn't fixing nothing, it's filtering it. So that would be the difference. Yeah, again, just more utilizing tagging and the higher level stuff like nouns, objects, phrases. I went over this, went to many videos before. Yeah, the narrow tag, the PLS tags, there's a keyword proximity scan. The actual network stuff comes in when you're actually utilizing this kind of data. You're not just scanning it, you're not just tagging it, but you're trying to mold it into something somewhere. And you're trying to make a prediction, and there's an error correction somewhere in there, not just filtering. The MoE model, I mean, again, that's just another model, a high level thing that it's not as complicated as it seems, in the sense of like you said, like a business, you have a CEO, you have managers, and you have the workers, you have the error correction, and then they have to move the weights and biases in order to correct the error ratio. Well, this is just another high level version of that. You're using experts, which are basically the workers. It's just each one of them has a certain role that kind of has its own CEO and manager and worker, and so the output that they output then gets compared, and it's like a neural network inside of a neural network. That's not really, I mean, it's complicated if you had to do it from scratch, but like I was saying from the beginning of the video, you just wouldn't do that. If you did do it, it wouldn't have a very good use case. I mean, someone somewhere had to do it for all this stuff, but they would have had a team and everything. I mean, it just wouldn't be one person. And a giant history of people doing that in teams. And they didn't have a mental model of what was going on. I can pretty much guarantee you that. Unless it was the very earliest version. Anyways, because like I said, you have to kind of consume and understand that you have to give up that mental model, sort of. As long as you know these concepts, and I did go over them in my blog thing. I made about 6 pages. I actually made 7, but I just didn't, I don't know. I was thinking to myself, this is getting such high level, and I have such a not, you wouldn't have a mental model of what's going on to the degree at which, what are you reading? You know what I mean? It's sort of just trust the process a bit, and just understand the terms and move things around a little and take what's given. based off of that. Nobody here is going to have the mental model of this high level of stuff. Like, it's just, like I said, even if you did build something that did, it wouldn't make a whole lot of sense because it would be such a simple use case. So this is the generalness of it. The experts, like I just explained, they're like mini neural networks. So it's just how the tokens and stuff are routed. Capacity is how many tokens. Load balancing is like, you don't want one expert to be the expert. You want them all to be experts. And that's what each one of these parts you probably could have a mental model of. Put them all together in some kind of holistic effect, you wouldn't. It would just be too intense. Especially because at the low level, anyways, with the different layers of weights and biases and the backward and forward function and so on and so forth, you wouldn't have the mental model anywho, but you also wouldn't have the mental model of all this together. So there's multiple levels that you just wouldn't have the mental model of, and that is okay. Noisy gate is just another way to route, the different the experts, the data, and to make sure that they're because there's a whole thing with how they consume data. It wouldn't just be give them the sentence and just have each expert look over. No, it also has to be, throughout all this different kind of data that they had trained on, randomized, and then maybe positive, and then maybe mock data, and so on and so forth, because you don't want them to be trained on very specific things. Otherwise, when something isn't in the training data, you're going to have to reprogram the whole thing. The hybrid thing, again, is just different models kind of put together. The graph thing, I think, is interesting just because it isn't just tagging. It's structured tagging. So you would have kind of higher order tagging, not just phrases and dependency relations, but just concepts. And then from there, it's tagged into different objects. And then, the RNN decoder. Again, this is just a big part of the model. The whole head thing is, and the attention is extremely complicated. I just tippy-toe into the blog. Again, that's probably one of the most complicated parts too of any model, and that just gets, you're not gonna have a mental model of it. I don't know what else to. It's good to understand the concept. It's good to be familiar with it, but you're just not. Nobody's gonna hold it in their head. That's just not gonna happen. Like I said, there's all different kind of gates, all different kind of routing, all different kind of layers, all different kind of customizations with the data. It's just, that's where the magic sort of happens. That's the brain, and it's only useful because you can't have a mental model of it. If you did, it was 2 + 2, no one would care. So, it just kind of goes over the data, what it's kind of trained on. So it does the conversational data that it kind of reads in. These are the different, just another names for the training data. They're not really that important. Although you can take paragraphs and plug them in to a lot of these, and like this one, or not that one. Oh wait. No. No. This one, it's a temporary file. I bet you a lot of these may not be using anymore because I've changed it so much. was one where it was just paragraphs of data, though. Yeah, here we go. Where just you can plug in paragraphs and it'll just read it like a book. Yeah, it's not that important. I mean, it is if you're. Another reason why I had to use the vibe coding was because of the shapes of the data are ridiculous, and so I mean, you're talking every kind of paragraph, every kind of word combination, a different shape for each one, and I'm not going to calculate that. So yeah, I used the vibe coding in order to calculate it. See, resize model output layer to match the sentence vocab size, so on and so forth. There's a lot that goes into that I just didn't want to touch because that would be ridiculous. Yeah, a lot of these are really complicated, high-end things that obviously vibe coding helped out a lot on. I just had no background on, and they're there to kind of do like I said with the RELU or the Dropout, where it's kind of massaging of data just for your models, and they can either be really useful or they can really screw you over. Again, stuff that I just wouldn't touch. I'll let the vibe code massage that data because I'm not. Because it's not just the data, right? It's the tagging, it's the send structuring, it's how the model interprets it, it's how it also filters it. It's there's just a million layers to it in order to get it to the point at which you can output some sends that may or may not make sense. I'm not doing that from scratch. But you could utilize these. These are different experts. Obviously, I doubled them, and so it's not quite equal, and so it's not correct. But it's getting there. Yeah, these are different train models files that it creates. That's how you run it. Yeah, tokenization. It takes each word, tokenizes it. Vocab lookup. To form the sentences. Just how the different models respond to it. All different ways of generating the tokens and everything, but it just gets really complicated. Filtering, so on and so forth. And then the brain part, which is the hardest part because you're doing sampling, you're doing filtering, you're doing all sorts of stuff in order to massage that data. I'm not keeping it all in my head because if I'm not keeping the neural network in my head and I'm not keeping all the layers in my head, I'm not going to keep in how I massage the data. And I guess you could say how each thing gets calculated along the way for each word, depending upon the conversation and the data. And this is just general stuff that the prompt comes up. I showed that in the last video. I did implement SIMD in there to make it a bit quicker, so it utilizes CPU more, and then the different training commands. But really, I think at the end of the day, this one's going to be the winner out of all this stuff. And although Word2Vec and MoE and all that are important, I think this train chat conversational thing is kind of where it's all heading, and but it is a little wishy-washy. I'm sure you have a lot of questions. This is tough. What are you gonna do? But wait, actually, this is the model files. See, I wonder why it listed this one here, though. Yeah. Yeah, that's the general rundown of what's going on. Why, if I were you and building something maybe from scratch that you like wanted, start with the tagging, just to have a ability to process text. It ain't gonna be a neural network, but it'll be a way to interpret text, and then from there, uh, I would not start with Bart, or even Mo. I would do whatever the newest, just because a lot of times um, it'll be just a lot easier to deal with, a lot easier to see if there's any errors and so on and so forth. The old models were bad for a reason. I'd probably use vibe coding a lot. Like I said, I put the blog in to kind of give you a general rundown of the concepts. I would go over that. I'd probably use Gemini in order to ask it questions, and maybe have some kind of questionnaire on yourself on it, just so that like basic concepts are stuck in your head. Like if you forget backwards and forwards. And then just kind of go from there and build up with it and try to figure out maybe some little use case thing or whatever. But I'm gonna just keep on trying to work on making these sentences useful and more conversative instead of just word salad. What did you do today? Yeah, it's getting there. Anyways, if you have any questions, please let me know. Hopefully that helps someone with something here. Thank you.